friends, welcome to 21 Days of Code with Ozone. Today, here I am with first problem for day 14 and the problem name is Reorder routes to make all paths lead to city 0. Now, we'll read the problem statement and try to understand the problem first. Alright, so the problem states there are n cities numbered from 0 to n-1 and n-1 roads such that there is only one way to travel between two different cities. This network forms a tree. Last year, the Ministry of Transport decided to orient the roads in one direction because they are too narrow. That is, they want to make the roads one way because they are too narrow to handle the traffic going in bi-direction. Roads are represented by connections where connections of I is equal to A, B represents a road from city A to B. That is, in the given matrix, they are telling that every element will constitute number of two different cities where city A will be origin and B will be destination. This year there will be a big event in the capital city 0 and many people want to travel to this city. Your task consists of reorienting some roads such that each city can visit the city 0. That is, we want to connect each and every city with city 0 with the given constraint that return the minimum number of edges changed. It's guaranteed that each city can reach city 0 after reordering. So, more or less the problem is trying to tell us that there is a network of cities connected by unidirectional roads and there is some mega event happening in city 0, that is the capital of that country. And what we basically want to do is that redirect some roads. That is, we need to change the direction of some of the roads so that each and every city can reach city 0. I hope it's clear now that what we are supposed to do. So now let's move forward with one example so that we understand that how will we be doing it and the idea behind this problem. So as in this example 1, you are given n is equal to 6, that is number of nodes are 6 and this is the connection matrix with connections representing from source to destination. So this represents a path from 0 to 1. Similarly 1, 3 represent path from 1 to 3 and so on and so forth. Now, what the problem here is that these roads are all unidirectional. So, a road from 0 to 1 cannot bring people from city 1 to city 0. That's why we need to reroute this road and change its direction from 0 instead of from 0 to 1 to 1 to 0. So that leads us to the solution of this particular example, that is, we'll need at least these 3 reorientations, that is this 1, this 2, this 3, because we need to travel in the opposite direction of the roads that they're meant to be. So that's why in this case the answer will be 3. Now it might not be clear at first, but we'll discuss it further so that you'll understand how do we approach this problem. You can try a DFS traversal here, that is, you can actually trace back path from each and every city and try to find a path that leads to city 0 through some other city maybe, and that's what we are going to do in this problem. But let us first also analyze the example number 2 so that it will be more intuitive to you to jump towards the solution. Given n equal to 5 and the connection matrix is given as 1, 0, that is a path from 1 to 0, path from 1 to 2, 2 to 3 to 2 and 3 to 4. Here, as you can see, the two paths that are marked in red are in the opposite direction that we need to travel. So we'll simply reverse those two paths and get a path from all the cities to city 0. Now, what I'm trying to explain here is that what you need to do is basically check for each and every city and get a path to city 0. And how do you do that? So for that purpose, we'll be using a hash chart. That is, what we'll be doing is that we'll be adding 0 to the hash chart first because that's the destination city, and then do a DFS traversal on this given matrix and keep on adding each and every node that's directly connected to city 0. For instance, if you are considering this example, there is a path that already exists from 1 to 0. So if a city can reach city 1, it can obviously reach city 0. So our task would reduce simply to making all the cities redirect to city number 1 because from there on we have a path. Now let's move towards the code so that you understand what I'm trying to explain. So the first step would be to sort the given array based on the increasing order of the number of city. That is, we obviously want all the cities to come to city 0. That is a increasing order. So that's what we do here. We are using the inbuilt sort function and passing the parameters collection array and sorting it based on the second indice of the particular connection. It will be more clear when we move further. Then, as discussed, we'll be using a hash chart. Initially, we'll be adding the node number 0 to our hash chart. Then we'll be having a list of routes that are left even after the primary connecting. We'll further discuss on it when we move towards the left part. Now we'll be initializing our count variable, that is the number of paths that need to be reversed. Then we'll be iterating over the connections array as we have discussed and perform a DFS traversal on this. So if path.contains I at 1, that is, if in a given path we already have the indice number 1, then we can simply add indice number 0 to that path. So we can simply add indice number 0 to our hash chart because we already have a path to that city, and we can go further from that particular city if there already exists that node in our set. Then else condition, if path.contains the city at index 0, that is, we have the starting point already in our hash set, but we don't have the end point that we are demanding for. So what we'll be needing is that we need to reverse this particular path that will increment our count by 1, and also will be adding this particular key to our hash chart. Else, if both of the given nodes aren't in our hash chart, then what we need to do is that we need to put this particular path in our left list. Now you might be able to understand why I am doing this, because there might be some paths in which both the constituent cities are not connected in either of the ways to any of the other city, and that will lead us to pushing that particular set of path into our left list, which we'll be further traversing later on. Now on the left list, what we'll be doing is that if path.contains I at 1, that is, we already have done a single pass over all the paths that existed in the given input array. Also, our hash chart contains all the cities that have a path to city 0. So now in this case, if path.contains I at 1, that is for the arrays in the left list, if a particular index already exists in our hash chart, then we can simply add the origin city to our hash chart. Else, the similar condition that we used for earlier, if path.contains I at 0, that is, we have the origin but not the destination, then we can increment our count because we'll need to reverse that particular road and then adding the destination to our hash chart. And at last we'll be returning count. Now let's try to run this code first. We'll also try this second example just in case. Alright, this looks good. Now let's try to submit this code. Perfect, it works as expected. Thanks for watching.